Okay, the Fibonacci sequence is something that appears in nature. It shows up in math and computer science quite a bit. I've linked you to another video that goes more into depth of the sequence itself and also the basic recursion, as well as why it makes a lot of sense to create a memory place, a cache, to remember once you've calculated a Fibonacci number. So just to clarify what these are, so this would be the first Fibonacci number, the second, the third, the fourth, the fifth, sixth, seventh, and so on. Any given Fibonacci number is created by taking the two previous numbers in the sequence. So this 21 comes from 8 plus 13. If we wanted to get the next number, it'd be 55 plus 89. With the one exception is we have to create the very first two numbers in the sequence. So the traditional Fibonacci sequence would be 1 and 1, and then after that you can just get every other one by adding the previous two. So what I really want to go through here is what's going on inside of the function when we call this, and hopefully you'll have watched the other video by now to understand the basic recursion. But let's say I've created this Fibonacci function here, and I've set it up with a cache like they did in the video, and let's say I call that function on, say, the number 4. So I'm getting the fourth Fibonacci number here. I'm essentially getting this 3 here. And let me actually run this so we have the function. There we go. So where are these numbers coming from? How do they get printed out? That's what I want to cover here. We're calling Fib02 on the number 4, right? So our x is equal to 4. So let me. That's what we're doing right now. So maybe we put something like x equals 4 here. So if x not in cache, what we're looking for is the number 4, one of the keys in our dictionary, and it's not. We've calculated the first and the second Fibonacci number, but we don't have the fourth Fibonacci there yet. So we're going to go into this if branch, and it says cache of 4. In other words, we're going to create it in the dictionary since it's not already there. But in order to create it, we need to know what the value is. So we look at here, Fib02 of 4 minus 1. That would be Fib02 of 3. We don't know what that is yet, so we're going to have to find out. So now, notice that we're still inside Fib02 of 4. We haven't reached this point, and in fact, until we resolve what this value is, the program won't continue to here, much less to this print statement or the return statement. So we're still trapped inside this Fib02 of 3. That's where we're at now. So let me just put here, so x currently now equals 3 inside this function right here. So we go through Fib02 of 3. If 3 not in cache, well, if we look in the cache, so far all we have is 1 and 2. So 4 was not in there. 3 is also not in there. So we're going to enter the if branch. Cache of 3. In other words, we're gonna set it up here. We're also working on 4, by the way, although we still haven't got an answer for 4. So cache of 3 equals Fib02 of, remember, x currently equals 3 here. So the Fib02 of 2, which means we have to calculate that. So now we're still inside this function, and now we're inside this function, and now we're in a third level of looking for Fib02 of 2. So x currently equals 2 here. Now here, notice that 2 is in our cache. It's right there. So we're going to skip over that if branch, and the function's going to return cache of 2. Well, the cache of 2, in other words, the value of the key that has 2 is 1. So Fib02 of 2 just equals 1. So now we're outside of this. This is equal to a 1. Cache 3 equals 1 plus, and here we go, Fib02 of 1. So now we're still inside this larger function, and we're still inside the smaller one inside that, and now we go into Fib02 of 1. So x equals 1. If 1 not in cache, well, 1 is in our cache. It's one of the keys in our dictionary. So we skip that and return cache of 1. In other words, return the value for the key of 1, which would just be 1. So now we know that this equals, for cache of 3, we know this equals 1 and this equals 1. So now we know that the cache of 3 equals 2. And this whole time, we're still trapped in that outer function that's trying to figure out fib02 of 4. We're still trapped in this little portion right here. We've never made it to this far in our outside function. But now in fib02 of 3, we've now made it through this step. So we go down to here, print, and we're outside of this now. Print x cache x. Well, x, where we are right now, is equal to 3, and the cache of 3 equals 2. So that's how this 3 and the 2, they're the first things to actually get printed. And then we return cache of x. We return 2. Our function returns 2. Remember, all of that was right here where we were trapped, and we now know that this equals 2. So now we're outside of this level. And now finally we go back all the way to in the beginning where we were trying to calculate cache of 4. We now know it equals 2 plus this. Well, what's this? Fib02 of 4 minus 2. That's Fib02 of 2. If we call Fib02 of 2, we'll see that 2 is in the cache. We skip this, and we get the value for 2, which is 1. In other words, cache of 4 equals 2 plus 1. So we can finally fill that in and finally move down to this next step where we print x, which is 4 currently, and then cache of x. In other words, the value for 4, which is 3. And that's how we get our 4 and our 3 right there. After we've completed that line, the very first function we ever called returns cache of x, which is 3, and that's how we get our final 3 right there.